Physics Lab 3. Intro. The purpose was to observe the motion of a planet orbiting a black hole and determine the mass from the forces. Important equations: force of gravity equals negative g mm of r squared r hat, vf equals vi plus f net over m delta t, and rf equals ri plus vf delta t. That's universal gravitation, velocity update, position update. The idea was to find the mass of the thing being orbited, given the velocity and radius of the orbit of the object of known mass. And the result, the mass of the black hole was 1.04205 times 10 to the negative, or times 10 to the 34, and a constant figure-8 orbit was not achieved. System versus surroundings. Part 1 system was black hole and planet. Part 2 system, planet, moon, and ship. And neither part had anything in the surroundings. Process assumptions and conditions. The process. The given starter code was edited to function correctly. The code was ran. The outputs were analyzed. And for part 2, numbers were changed until a figure-8 was achieved. Assumptions. As the models are in space, there's no air resistance. In part 2, the spaceship is treated as a point mass. The black hole in part 1 and the planet in part 2 are stationary objects. Conditions. Part 1, the mass of the star was 2e to the 30. The delta t was 86,400 seconds. Part 2, the planet mass was 8e to the 27, the moon mass was 6e to the 25, the ship mass was 7e to the 12, delta t was 60, t was 0, VIX was 20,000, VIY was 30,000. This is the model. The model is given in the procedure. The initial conditions were changed. Momentum change / net force calculations were added, and the update formulas were input. That's all shown in the figure to the right. The part 2 for the model was given in the procedure. Gravitation forces and net force calculations were added. Update formulas were input. The initial velocity was appended until a figure-8 orbit was present, sort of. Results. Part 1, the orbital motion of the planet around the black hole. The mass of the black hole was found to be 1.04205 e to the 34 kilograms. Part 2, the figure shows the interlocking orbit of the ship around the moon. A figure-8 was not really achieved, but I did my best. The initial velocity used was 20,000, 30,000. What does it mean? While the rate of change of momentum is equal to the net force, they are not the same thing in theory. Rate of change of momentum is the change in the velocity of an object multiplied by its mass over time, while the net force of an object is the instantaneous accelerations of an object multiplied by the mass of the object. And to compute the entire system, the gravitational forces between every object would need to be considered. There would be dominant forces. The gravitational forces between the objects with high mass would be the strongest, while the ones with lower mass would be more inconsequential. So the one like the black hole and the planet would be the highest force, etc. Possible error in the random value for G would be a compounding error over every iteration. Conclusions: the mass of the black hole was 1.04205 times 10 to the 34 kilograms. It is very difficult to achieve a figure-8 orbit with a stationary planet and an orbiting moon, and to model a system with objects of high mass, the gravitational forces of each object in said system must be considered.